Alrighty, test 1 2 1 2, test 1 2 1 2. Hopefully we're live here. So if we're live, let me know. If not, let me know. Just testing some random characters, and it looks like my screen is being shown, so that's good. Just making sure my audio is all good as well. So, if you're new to the channel, lately I've been doing a lot of these Leetcode grind streams. I do have a meta interview coming up, so I thought I'd just vocalize all my thoughts and stuff like that for this particular channel here. So, if you're new, if you're just joining us, welcome. My name's Donald. I do programming interviews and whatnot. So, feel free to stay by, watch me Leetcode. If not, if you're just stopping by, always happy to have you as well. So yeah, without further ado, we'll get into it. So I did this problem yesterday. I kind of struggled with it. I did a little bit this morning as well, but I didn't get it as to my standard. I want to make sure that I can just spit out the code flawlessly without any hesitation. And I want to make sure that I get the ideal solution as well. So that's kind of where we're going with that. So let me just set up some stuff here on the back end here before we get our stuff started. Again, hope you're tuning in. Hope you guys are doing well this weekend. And yeah, let me just set up some stuff here on the back end here. Alright. So, basic calculator. What I'm going to do is I'm going to paste in the engineering method template, which is something that I learned from Formation. I might talk about this a little bit in a further video. But basically what the engineering method really states is there's 3 or 4 aspects. There's explore, brainstorm, plan, implement, and verify, right? So explore is what are some insightful and revealing test cases. So in this case, what you would do is you would see that 3 over 2 is going to return the floor of that, right? So for division, return the floor of the value, right? So another thing you might notice is it follows pen mass. Another thing you might notice is you have some white spaces. As you can see here, there are a little bit of white spaces, right? So we don't want to process that. So what are some things that could work here? You could use a stack, right? That would result in you doing O of n and O of n. But can we do better is the question. And you can do better in terms of the space. So you could do no space processing, which is going to return an O of 1 or a constant time solution. So what we're going to do is I'm going to code out the constant time solution here. So what is going to be the outline? Well, the variables we're going to need is we're going to need current number, last number, answer. What else do we need? We will all to be initialized to 0, sign initialized to a string of the plus sign. We're going to iterate through each character and index of the enumerated of S. If we see that a character is a digit, we current number equals to the current number times 10 plus the integer of the character, right? Now the reason why we do this is because let's just say that we had a double-digit number. We want to iterate to make sure that we capture the entire double-digit number. So in the case that we have, say, 22, we want to make sure that we're getting all of 22. So that's what this formula is actually doing, right? Else, if we have a character that is not a digit and a character that is not a white space and a character that is in bounds, we have to see that. So this condition just makes sure that we're in bounds and that there's a possibility that it's going to be a sign, right? So check if the sign is a positive plus, or not a positive, but plus or minus. If so, add to the string, or the result rather. I'm going to be more specific here and say last number to the answer, right? Then we want to set the last number, right? So the sign is a plus, let last number equal to the current number. If the sign is a negative, let last number equal to the negative current number. Alright? Else, if the sign is a multiplication, let the last number equal to the last number times the current number. Else, if the sign is a division, let the last number equal to the last number times the current number, or not times but divide. Reset the current number to 0, and we're going to set sign to chunk, since we're doing each character an index of enumerated. This should be S. And then outside of the loop, we're going to add the last number to answer, return the answer, right? So that's how algorithm 2 is going to work. So we're going to set number 0, last number to 0. We're going to set ans to 0, sign to and we're going to do for in I char in enumerates S. Alright, so we're going to check if char dot is digit. We're going to set current number equals to 10 times current number plus integer of char. If char not char dot is digit, or and not char dot is space, or I is equal to the length of s minus 1. So what we're going to do is we are going to check if sign is equal to plus or sign is equal to minus. So we're going to add it to answer first. I'm going to add last number to answer. If sign is equal to plus. You can do this a lot more succinctly, but I like to illustrate it to make it a little bit more clear. That's what I like to do, and it helps me to better understand it anyway. So that's why I'm doing it this way. I know there's a more Pythonic way to do it, but that's how I'm going to choose to approach it. If sign is equal to negative, last number is equal to negative current number, and then if sign is equal to positive. My thing is in the way here, so my apologies for this. Let me just... And then C. Lee Oloma says, good luck on your interview. Thank you very much. I'm just doing whatever I can to do it, to prepare for it. I'm trying to record all my grind streams here to be totally transparent with you so that you can see my struggles, how I overcome them, and stuff like that. But anyway, getting back to the problem here, last number is equal to last number times current number. If sign is equal to division, last number equals to last integer divided by current number. Now the last thing we need to do is we need to reset sign, char, and current number is equal to 0. Because assuming that we get to this point, current number has already been processed, so that's why we're resetting it to 0. And then lastly, outside of this loop, we're going to add the last number to answer just in case that there isn't any in the answer, right? And then we're going to return the answer. So let's see what she does. Accepted, and we are good, right? So that's going to be basic calculator for you. So what question should we do now? I think what I'm going to do is I'm going to go down the list. So is there any interesting problems that I really want to work on today? Merge it. Yeah, we're just going to go from the top now. Python. Alright, so merge intervals. Given an array of intervals where intervals I is... Okay, let me just start the timer because we're really concerned about that. So given an array of intervals where intervals I is equal to start n, merge all overlapping intervals and return an array of the non-overlapping intervals that cover all of the intervals in the input, right? So what I'm going to do here is I'm going to practice using the engineering method. So over here, explore what are some other insightful and revealing test cases. Well, I've done this many times before, so I know that one of the more insightful and revealing test cases in this case is going to be the fact that intervals can be out of order. Intervals can overlap, obviously. So those are the two more insightful kind of test cases and conditions that we might want to consider here. So there's obviously one approach that could work here is the interval solution. And this is going to be an O of n log n, and then O of n to store the solution, because we do need to use an array. So basically how this problem is going to work, in a nutshell, is first you have to sort the intervals, initiate answer array, iterate through each interval in intervals. So if answer is empty, add the intervals to the ants. If the latest answer value at index 1 basically means that it's going to be this top value here. So 3 is greater than or equal to the interval at index 0, merge together. So how do we do that? Merge together by calculating the min interval to be the min of the top answer value at index 0 and the interval at index 0, as well as the max interval as the min max of the top answer value at index 1 and the interval at index 1. And I'm going to make this a little bit more succinct, or maybe not. I'm going to make this a little bit more clear. So else add the interval to the answer. Then we're going to return the answer. All right. Let's begin coding now. So intervals.sort answer is equal to open bracket an empty array for interval in intervals. I'm gonna set everything up here. If not answer, ants.append interval 0 interval 1 else elif answer -1 1 is greater than or equal to interval at 0 min interval is equal to min of ants -1 0 and interval 0 max interval is equal to max ants -1 1 interval 1. Else, we're going to copy what we have here, and that's going to be our answer. Or, I forgot. Ans -1 is equal to min interval max interval. Alright, let's see what she does. Accepted, submit, and we're all good. So 5 minutes, 56 seconds. Cool. Let's go to the next one. So as you can see, this is basically the problem set that I'm working off. So kth largest element in the array. So I've already solved this before, so I'm going to clear this, solve it again until it becomes second nature. And we're going to use the engineering method again. Alright, so what are some insightful and revealing test cases in this case? So this one, you can have negative numbers. And it looks like you have a minimum of 1 value in the array. Alright, so algorithm 1 is sorting. So this is going to result in you having an n log n solution with constant space. Because if I think of it the way that I envision it, you don't really need to use any additional data structures, but you do need to use, you need to sort it, so it's not as efficient time-wise. So algorithm 2 is going to be the heap solution. And that's going to be O of n log k, I believe. And it's going to result in O of n space. So obviously this one's going to use a little bit more memory, but it's going to be a little bit more efficient time-wise. So depending on what your interviewer wants to do, it will depend on what solution that you go with. Either way, this solution is pretty simple. So what you want to do is we're going to code out algorithm 2 here. So initialize heap, iterates through each num in nums, add to heap, pop length of nums minus k, values from the heap, then return first instance of the heap. So that's basically how the algorithm is going to work. So we're going to initialize the heap. I forgot to set my timer, but whatever. Num in nums, heap push, and then we're going to change this to num for blank in range length of nums minus k, heap pop heap, and then we're going to return heap at index 0. Accepted, submit, boom. So that didn't take too long. Binary tree vertical order traversal. So let's reset the timer this time. Paste in our engineering method template here. All right, so press play. Given the root of a binary tree, return the vertical order traversal of its nodes values, for example, from top to bottom, column by column. If the two nodes are in the same row and column, the order should be from left to right, right? So let's see here that we can, I'm assuming that we can have null check nodes. So that's something that we might need to consider here. So root 3, 2. So now we have to brainstorm how we're going to be able to do this. Obviously, this is a tree problem, right? So one of the things that we can do is we can use either BFS or DFS, right? So obviously these two would work ideally, right? But one thing you have to consider with the DFS solution is the fact that you may need to store where you are in the array and the I guess the value of, or not the value, or the value of the, how do I describe this? So you can see here that 301, you know that 3 is on top, so you need to store that particular value in the array. So I think for this approach, you can use two solutions. You can either use DFS or BFS, right? So what approaches could work? DFS is going to be O of n and O of n. So we also need to store it in a hash map because we need to store what position that we are using it in, right? So that's something that you might need to consider. And then algorithm 2 is going to use BFS in a hash map, and that's exactly the algorithm that I'm going to partake on, right? So I'm going to null check the nodes, make sure that the nodes are valid, i.e. if not node, return an empty list, launch the queue and the hash map both as empty. So add the queue, add the root and the depth of 0 to the queue while queue is not empty for each value in the queue. Pop the node and the depth from the queue. If the depth is not in our hash map, set the node at, or the hash map rather, depth to be an empty list. Otherwise, add the node.val to the hash map at the depth. If nodes exist, left and queue them. If nodes exist in. So actually, we're going to need to sort this, so it's going to be O of n log k, or n, right? Because you do need to sort it at the end. Queue them. So sort the hash map. So I think we need to enqueue each node at worst, and then we need to sort at most n log n. Yeah, so that's going to be the time complexity there. Values of the hash map. By its key values. All right, so return empty list, q is equal to collections.dq. What else? Hash map is equal to empty. We are going to q.append root 0 while q for blank in range length of the queue. Alright, so I'm gonna make sure this is a little bit bigger for you guys. Q.top left depth notes in hash map at depth is equal to empty list hash map depth dot append node dot value, because it's a value object here. If node dot left q dot append node dot left depth -1, because we're going to the left hand side. If node dot right q dot append node dot right depth +1, and then lastly we're going to, let's see, how can I do this? So I can do return dict sorted dot items dot values. I wonder if that will work. What the fuck? Hold on. If depth not in hash map, and then we're going to go hash map at depth is equal to empty list. Otherwise, we're going to, if why is the fucking dot append node dot val if node dot left q dot append node dot left depth -1 if node dot right q dot append node dot right depth +1. Let's see if that'll work. Unindent does, why the fuck is this doing that? God damn it. So I'm going to copy paste this and reset it because I don't, stupid Leetcode. Alright, so let's start over. Turn empty list. Q is equal to now Q. Oh, I forgot to add values. you. Hash map. Val, and then if node.left q.append node.left def minus 1, if node.right q.append node.right def plus 1. Now we have to sort the keys or the hash map by its keys. Dict sorted hash map dot values items rather dot values. There we go. And boom. So there we go. So that's how you do that. A little bit of a hiccup because of Leetcode, for fuck's sake. But yeah. Now we're going to move on to minimum remove to make valid parentheses. I'm going to use the engineering method as usual because that's something that I want to focus on. Because that's something that I want to simulate during the interview process here. So, let's see. Let's reset the timer, go through it. So before we do that, I'm going to quickly run to the washroom. So I'm going to be right back, guys. Don't go anywhere. Alrighty, I am back. So, let's see here. Anyway, let's press play. So, given a string S of open parentheses and close parentheses and lowercase English characters, your task is to remove the minimum number of parentheses in any positions so that the resulting parentheses string is valid and return any valid string. Formally, a parentheses string is valid if and only if 1. It is the empty string containing only lowercase characters, or it can be written as A concatenated with B, where A and B are valid strings, or it can be written as A, where A is a valid string. So we're given an example here where S is equal to Leetcode. So you can either remove the last parentheses or the one between 0 and D, right? This one, you're going to remove the opening one over here, right? You're gonna keep these around. This one, you're gonna remove these, and then you're gonna remove these. So how exactly do you approach this problem? Well, we can use a stack, right? What we want to do is we want to check if our stack is, so we can use a stack. So primarily we use the stack to how do I say this? Process the open parentheses. So if our stack is empty and we see closing parentheses, we want to remove that character as we know it's invalid, right? But we can see here that these ones, the stack would be empty, and then we get random open parentheses. So how do we do that? At the end, we want to check if the stack is, I can't spell today, and if so, we want to, how do I say this? Pop all the elements, or not pop all the elements, but set all the open parentheses to empty so that we remove them from the array, right? So obviously the one that we can think of is a stack solution. The time complexity is going to be O of n and O of n. And then we're going to have an outline of algorithm 1. So what we're going to do is we are going to initialize the stack for each index and character and enumerates of s. What should we do? Check if character is an open parentheses. Another thing I want to do as well is convert the s into a list of characters so that we can remove them. Alright, check if the character is in open parentheses. If so, we're going to add to the index to the stack. If character is closed parentheses, check if stack is empty. If so, set the index string at the index to be empty. If not, pop from the stack. If the stack is non-empty, take all the values and set the string at that index to be empty, or pop each value from the stack and set to an empty string. Since the answer is in array form, we want to convert back to a string format and return that answer. Alright, so that's how the algorithm is going to work. So let's code her up, move out my speaker for now and just enjoy the code and the ASMR. So do. Nope. If tries to Alright, that's all we need to do there. Run. Boom, 7 minutes. There you go. So, next problem. We're doing well. Subarray sum equals k. So we're going to paste in the engineering method and go through that. But before we do that, we're going to take a little break. I'm getting a little bit fatigued here. So I'm going to do a little bit of a refill of my water bottle, and then we'll be right back. So I'm going to reset everything here. Get a little bit distracted. So we see that there's 2 people watching right now. Always happy to have you guys here. And if you have, I'm probably going to do these Leetcode grind streams on a consistent basis here. So if you are enjoying these, let me know in the comment section below what you think of these. I think these are good to kind of keep my mind fresh. And yeah, so let's take a little bit break here, get a little bit of an intermission, and then we'll be right back. All right. Alright, so I am going to end the live stream for now. I will be back for another one during lunchtime, so I'll see you guys in an hour. And